but this is going to go into here.
Well,
and the trick to doing this, if it actually works, is the same principle as making a cocktail. Has anyone ever drunk a cocktail where the layers are all fancy and it's banded and... Well, what you're actually doing is arranging things according to density, according to how heavy they are. And a liqueur with a lot of sugar in it in a cocktail is going to be quite dense and it's going to stay at the bottom. And you need to carefully pour it under the less dense, lighter spirit. In the case of salinity, we're going to do just the same. The saltier water is heavier. So with the help of Dill and her funnel, we are going to carefully pour the higher salinity layers through to the underneath, and hopefully it will arrange into different layers, different salinities, and the dyes will help us visualise that. Then Ben, shrimp wrangler, well, not yet, wait until we've got it all set up, because they've got little swim racks that paddle and mix up all the layers. That's why we've only got little shrimp, because if you do it with a great big guy, it'll just mix the whole thing up. Okay, so is everybody sort of clear on what we're doing? Yeah? Pouring shrimp and fluorescent water into a bucket to demonstrate behavioural osmoregulation. Right, Dill, hold that quite tight. So we'll have this is normal salinity seawater. The fluorescent yellow seawater is 3 times concentrated, it's more salty. So what we're going to do now with the pouring, you need to be quite careful. If you introduce a lot of air bubbles, it might mix it up. So you need to pour steadily and sort of more or less straight down the tube. Try to aim for the middle and not let any air bubbles come in. Keep pouring. This is working better than last week. Hooray! Okay.
Am I supposed to be recording?
Oh, yes, you can record now.
Great.
If you record what they're doing, and then if you can get down and actually take a side view of the tank. So we're doing this 6 times. One of these times we're going to get, it's on YouTube anyway. Okay, so, Dale, if you could just, no, keep the funnel, we're going to pour some more, but if you could just stand back, would you just like to get a good shot of how... If you'll bend down and have a look, we have a clear layer of ordinary salinity, and then we have the other layer of 3 times concentrated seawater underneath. So those layers are staying apart because of the difference in density, the difference in salinity. The salty layer is heavier. The dye is nothing to do with the separation, it's just so you can see it. So our next volunteer, who has 5 times concentrated seawater, dyed red, extremely salty. So if you want to come round, yeah, any way you like, and just pour this through Dill's funnel. Again, try not to get any air bubbles. So aim straight for the tube, slowly and steadily. Sort of, yes. This is kind of working. Keep going. Getting quite a lot of air, so if you just pour quicker. I think our top layers are mixing a bit, but that's okay. Right, now we can remove the funnel. And can we actually see now? The top layers have mixed a bit, but we've got this very clear red layer of dark salinity, of higher salinity. So we have 5 times concentrated seawater, 3 times concentrated seawater, and a clear layer at the top. These have mixed up a bit, but as long as we're quite careful, it's now time to introduce the shrimp. And then we'll be able to see which salinity the shrimp actually prefers. See if you'll actually engage in behavioural osmoregulation and select to swim in the salinity that most closely reflects his
They're faster than you are.
yeah, now they will jump, so yeah, and okay, in goes Crangon, a shrimp that's commonly found in rock pools. And what's he actually doing? So the normal behaviour of these shrimp would be to go down to the bottom to hide from predators. Normally they'd go where it's dark on the bottom to keep away from predators, particularly if you'd just been chased by Ben with a net. You would want to hide, right? So, so hopefully, I can't quite see what he's doing, but he's keeping off the bottom, isn't he? Normally they'd sit on the bottom to not waste any energy, and so he's trying to swim in that upper layer. Yeah, every time he drops down, he's having a quick paddle to get back. And like I say, this is not the normal behaviour. Normally they'd conserve energy staying on the bottom to stay away from predators, but he's actually using less energy by swimming really hard than he would be by actively pumping ions, actively pumping that salt out of his blood. So before Little Shrimp's fed up, can we have another volunteer who will use our salinity probe and actually measure the salinity in each of those layers? Jenny, how do I switch this on? Do I just press?
Go on.
Right.
You do it.
Can we have another volunteer? You. Right, so Jenny, we're reading the right thing. What salinity is it in? It's saying 82.2. That's not right, is it? Do I need to press mode or? Is that, so is this in water? So, I think this was measured as 27 first thing this morning. That's looking right. Okay, so it's going to take a bit of time to stabilise. So let's just measure the salinity of the top layer. So what's that reading? Can you tell everybody?
29, 28.
Okay, so the salinity of that is about 28, 29. Can you go down a bit into the yellow layer? Okay, so now the salinity is higher. So this is just checking that we've got the right salinities here. This is 37, 38, yeah? And now right down to the bottom layer. Has that gone off the scale? Poor Mr. Shrimp. I wonder. Okay, wow, so that's quite high, isn't it? That's. Do you want to tell everybody what it's reading?
55.1. Yeah.
Okay, so we've clearly got a gradient of salinity, just like with having a rock pool. So this may well be something that a shrimp or a crab or another animal in a rock pool would encounter. And clearly, animals that can move will move to get away from that high salinity to hang out in an environment where the salinity is closer to the osmolarity, the salt composition of their blood. Okay, you all now convinced about behavioural osmoregulation? Yeah? Okay. Yeah, you can take that out now.
You could actually use this if the layers were a little bit more even. Put a ladder in it with some shore crabs, couldn't you? And you could see where they climb to on a ladder, according to salinity, pH, temperature. So in a year's time, when you're doing your honours projects, you could think about this as perhaps, if you're interested in marine physiology, as a model for using in your honours projects. So you could have lots of tanks set up, replicates, and vary the temperature and the pH. And you don't have to use a shrimp, you can use another animal.
The shrimp are kind of fun though.
Yeah.
Okay, right. Ben, would you like to collect Mr. Crangon and put him back with his friends because he's working very hard there? Oh. Okay. Okay, good job. Well, thank you to all the volunteers. Thank you, Crangon. You did. What's quite interesting is you can see he's got a funny